Let's talk about differentiation formulas. In the last section, we learned how to calculate derivatives using the definition of the derivative, and this can be a little bit tedious. So in this section, we're going to learn formulas that will make taking derivatives much easier. So our basic strategy is we learn the derivatives of basic functions like f of x equal to x, or f of x equal to some constant c, and then we learn how to combine these basic functions in different ways. And we learn how to calculate the derivative of this new function that's a combination of these basic functions. So the first theorem we have is the constant rule. And the constant rule tells us how to find the derivative of a constant. So we write our constant c, let c be any constant, and then I'm going to put my differentiation operator there. And the derivative of any constant is going to be equal to 0. Okay. Now, I can prove this one for you. We could use the definition of the derivative to prove this. So we know that the derivative of the constant function is going to be the limit as h goes to 0, f of x plus h minus f of x, all divided by h. Now in our case, f of x plus h is just a constant, so that's the limit as h goes to 0 of the constant minus f of x is also a constant, that's just c, divided by h. And when we simplify the numerator, we're going to get 0. So we're really finding the limit of 0. And the limit of 0 is just 0. So that's why we have our differentiation formula for the derivative of a constant. All right, let's take a look at a simple example. What's the derivative of 8? Well, if I differentiate the constant 8, guess what you get? You get 0. Cool. Let's talk about the next big rule that we learn. We learn about something called a power rule. The power rule allows us to find the derivatives of monomials. Mono means one, so a monomial looks something like x to the n. Okay, and in this particular case, n is a positive integer. Now, this formula looks a little bit more interesting than our previous formula. We're going to write down our monomial x to the n. We're going to put the differentiation operator to indicate that we're going to take the derivative. And this is how it works. You're going to bring down that exponent in front. So you're going to multiply by the exponent. You're going to write your variable x, and then you're going to subtract 1 from the exponent. And this is what we call the power rule. So I'm going to highlight this. This is one of the basics of calculus. Okay. And why don't we take a look at example? Let's look at example 2. Example 2 says find the derivative of f of x equal to x to the 7th. Okay. So when we go to write f prime of x, we're going to bring down the exponent. So in this case, that exponent is 7. We're going to write our variable, which is x. And then we're going to subtract 1 from the exponent. So 7 minus 1 is 6. Okay. Let me give you another example just for fun. Let's say I had something like find the derivative of x to the 88 power. In that case, what would you want to do? Well, you want to bring down the exponent. So you have an 88 in front. You write your variable x. You subtract 1 from the exponent. 88 minus 1 is 87. Okay. So these are some of the basic functions that we've learned how to take the derivative of. So maybe I should come back to the top of my page. I could really tack an n on to my f of x here, so I can make this an x to the n power, because I've just generalized what I know. And we're going to now be able to combine things to get new derivatives. Let's take a look at the sum rule. So let's say I have the sum of two functions, f plus g of x, and I want to find the derivative of it. The way that I calculate that derivative is I'm going to take the derivative of the first function and then add what I get when I take the derivative of the second function. Okay, so let me highlight that guy because this is, again, one of the main rules we use all the time in calculus. I think we have time for a quick example. So let's differentiate x to the 7th plus x to the 88th power. And then we know that you could just, to differentiate this entire function, you could just take the derivative of each piece. And then that's just going to be 7x to the 6th plus 88x to the 87th. Okay, great. So the next rule we want to learn about is something called a constant multiple rule. If I have a constant times a function, and then I want to take the derivative of that guy, what this rule says is you could factor the constant out of the derivative. Okay, so I'm going to highlight that guy because it's a big deal for us. Use it all the time. And let's take a look at example 3. In example 3, we want to find the derivative of f of x over here. Let me write it like this. I'm going to have the derivative of 5x cubed. According to the constant multiple rule, I could factor out the 5 and take the derivative of just x cubed. And then I apply the power rule. I'm going to get 5 times 3x squared. And then I can simplify that to be 15x squared. All right, so this would be my final answer. So we'll work on more examples together in class, but let's finish off this video by talking about the product rule. So for the product rule, I'm going to have two functions multiplied together. So I'll have fg, the product of x, and I want to take the derivative of that guy. Now this rule does not work the way most students think it does. So I almost feel like I should put like a star here and a star here. Just pay special attention, you know. This is how it works. Watch closely. You're going to take the derivative of the first function, f prime of x, multiply by the second function, g of x. You're going to add, now you're going to take this derivative of the second function, g prime of x, and then you're going to multiply by the first function, f of x. And this whole thing here is something called the product rule. Okay. So this does not work the way most students think. Most students just take the derivative of f and then the derivative of g and multiply together, and they get it totally wrong. So that's why I put the stars here. Don't do that. It's kind of this more unusual looking thing here. And you can look at your textbook and they'll give a detailed proof for why this is true. I'd rather do an example with you. So let's take a look at example 6 together. If I want to find the derivative of h evaluated at 2, that's going to be h prime of 2, right? And I need to use the product rule. So I'm going to take the derivative of f prime. I'm going to plug into 2. I'm going to multiply by the second function, which was g, and plug into 2. Then I'm going to add when I take the derivative of the second function, g, plug in the 2, and then multiply by the first function, f, by 2 like this. Okay, so I hope you could see that all I did was I called my h prime this derivative of the product, and then I simply applied the product rule formula. It's the derivative of the first times the second plus the derivative of the second times the first. Now, since they tell me what each of these numbers are, if I carefully substitute, I can get the answer. So f prime of 2 looks like that's -4, and g of 2 looks like that's 5, and then g prime of 2 looks like that's 6, and f of 2 looks like that's 3. So when I simplify, this is going to be -20 plus 18, which gives me -2. All right. All right, folks. We'll look at many more examples in class together. You'll have an opportunity to practice then. Take care.